Intro. Calculus, final exam review, part 2, Mr. Laverd's class. Actually recording this time.
Hopefully. Cross your fingers.
Knock on wood.
Let's see.
And we're back.
And we're back. Welcome back, everybody. Yeah, let's see. Yes. And we're paused. Now let's see. I want to go back and hide. I want to go back and make sure that this is actually recording. Is this actually recording? Have we made it past the 14 seconds? Okay, we're good. We're 40 seconds. Okay. All right. Well, hopefully it stays recording. I see my little icon for the microphone down there, which means I'm still recording. Hopefully it stays. If anybody notices that microphone has gone out, say like, hey, woo, so you're recording again? Yeah, please do those noises. Okay, here we go. All right, graph the function given the following guidelines. Be sure to show all work to support your answer. Domain, intercepts, symmetry, asymptotes, intervals of increase and decrease, extreme values, intervals of concavity and inflection points. And then we're going to graph. Yes?
Do we still need to bring in our math textbook?
Yes, please. Yes, bring in your math binders whenever. You have until next Friday to do so. Deal? Okay, thank you. Thank you for reminding me. What's that?
Can you do a remind?
Do I have a remind? Did I do a remind for this class?
Oh.
You have a reminder.
I remember you
Did I?
sending something.
Did I?
You
It was just
used to be
And then I just got it. Okay. Maybe I will. Maybe some random time I'll be like, hey. What's that?
Yeah, do we?
If the board says it. Okay, so let's start with the domain. Well, what kind of function is this? Isn't this just polynomial? So what is the domain and range of any polynomial? I mean, cubic. Domain is going to be all real numbers and range is going to be all real numbers. So first part here is pretty easy. The domain is all real numbers and the range is all real numbers. Especially since it's a cubic. Okay, so let's go for the intercepts now. Finding the intercepts. Now, remember, for the intercepts, I said x to the third plus 2x squared minus 8x equal to 0. So let's factor out the x. That'll give me an x squared plus 2x minus 8. So that'll turn into x plus 4, x minus 2. So we've got zeros at 0, negative 4, and positive 2. So those are my zeros. Let's see if is there any symmetry? What's wrong, Christian? You all right? You good, bro? Where'd the 2 go?
Oh, wait, no.
We factored, Christian. All right. Is there any symmetry? Nah, there's no symmetry. All right.
Yeah, you are feeling correct.
This is like one of the last classes I get to teach you. What's wrong? Uh-oh. I see 2 hands. Greg, what's
I
up?
just have a question like for your factoring. Why don't you take an x squared for b?
For B? Because this doesn't have a squared?
Oh, I see.
Okay.
It's not odd.
Is it odd?
I think it's odd.
Ooh, whoops. Sorry. I just assumed that it was none.
No, you're fine.
Let's see. If we plugged in negative, f of negative x, what would that be? That would be negative x to the third plus 2 times negative x squared minus 8 times negative, that's a negative x. So that would be f of negative x is equivalent to negative x to the third plus 2x squared. That doesn't change though. And I think that's our issue. Plus 8x. So no, it is not odd. It is not odd. Because if I took f of negative x, and I pulled out a negative here, this would be x to the third minus 2x squared minus 8x, which is not the same. Yes? Remember that even symmetry f of negative x is equal to f of x. That's even symmetry. Right? So if you plug in the negatives, all the negatives will go away, and it'll just go back to your original. If it's odd symmetry, f of negative x will be equal to negative f of x. Right? So if I were to have pulled out the negative and gotten back to the original, which was close, then it would have been odd, but it didn't happen like that. If that was just a +2 right there, then we could say that it would have been odd, but it's not. So, it's not. So there is no symmetry here. I was correct in saying that. Yes, you're bad. Take it back. All right, so there's A, B, and C. D is asymptotes. Now, are there any asymptotes to a polynomial? Nope. There are no asymptotes either. You'd only be looking for asymptotes if it was like a rational function. You know, if it was a fraction, you'd look for zeros in the denominator, and then you'd look for places where things cancel, or any horizontal asymptotes at the top heavy, bottom heavy, so on. But this one's just polynomial, so there are no asymptotes either. And then intervals of increase or decrease. What do I have to do to find the intervals of increase or decrease? Find the zeros of the first derivative. Good. So let's take a look at that first. Let me get this symmetry nonsense out of the way. Okay. All right. So f prime of x is 3x squared plus 4x minus 8. Right? 3x squared plus 4x minus 8. And now I find the zeros of the derivative. Does that factor? That's a bummer. Okay, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we've got 16 minus 4 times 3 times negative 8. That's my discriminant in there. 112. Negative 4 plus or minus the square root of 112 over 6. You good, Kate?
Yep.
100%? Do I even need to grade it?
Hopefully not.
Good. I don't need to. I better. We've got negative 4 plus the square root of 112 over 6, which is 1.09 or 1.1. And then we do the opposite, negative 4 minus the square root of 112. Divided by 6.
Do you need to do the full quadratic, or could we just find the zeros with the zeros?
Oh, that's so lame. Just do the full quadratic. It's like a mental exercise. What? Don't even say that to me.
Did we need it on the last test?
I don't think so.
Oh, well, I tried using it, but then I forgot it.
Where did you try to use it? On the integral test?
Yeah, the last one I took.
Oh, okay. I'll
Yeah.
have to look back and see what you did. So here are 2 zeros. Now, so to do the increase-decrease test, we look at negative 2.4 and 1.1, and we plug in some values to see what's going to happen. Because those are either possibilities of maximum or minimum values. So let's see what's going to happen somewhere to the left of negative 2.4. So say negative 3. Let's do negative 3 to the third power plus 2 times negative 3 squared minus 8 times negative 3. And that gets me a positive number, which I assume and now it's going to make it positive, negative, positive. But let's double check. If I plug in, I went into, I'm sorry, that's going to give me a 0. I don't want to do that. I went back into the original. That was stupid. hold please. I have to go back into the derivative. 3 times negative 3 squared plus 4 times negative 3 minus 8. Okay, it's still positive. Okay, still positive. Doesn't change anything. Now, when I plug in 0 into my derivative, that's going to give me a negative number. And when I plug in, let's say 2, let's try that. 3 times 2 squared plus 4 times 2 minus 8. I would assume that it's going to give me a positive number again. Yep, positive number. Okay, so that means this function is increasing from negative infinity to negative 2.4. Whoa. And from 1.1 to infinity. And then decreasing from negative 2.4 to 1.1. That's where it's negative, where the derivative is negative, right? Okay, now let's define where the extreme values are, because that's the next step. F says let's find where are the maximums, where are the minimums. And we can tell that just by our increase-decrease test. This is increasing and then decreasing. So that means negative 2.4 is a maximum. And then minimum at, because it's decreasing then increasing, at 1.1. Did I say to give the full coordinate? Yep. Well, then I'm not going to. I'm going to be lazy. Okay, now intervals of concavity and inflection points. Intervals of concavity. Now, what do I need to find next? The second derivative. Yeah, and I need to find the zeros of the second derivative. Those are the possible inflection points. So if the first derivative is 3x squared plus 4x minus 8, f double prime of x is 6x plus 4. Subtract the 4, divide by 6, negative 2/3. X equals negative 2/3. That's my inflection point. I guess I should check that. I've got to do a number line test at negative 2/3. And then we run, let's run 0 back in. That's on the right side. That's a positive. And if I run negative 1 in, that's going to be a negative. So there is an inflection point. It does change from concave downward to concave upward at negative 2/3. So we can say concave down from negative infinity to negative 2/3, and concave up from negative 2/3 to infinity. Okay, that means there's an inflection point at negative 2/3. Okay, that's a doozy of a problem. We still haven't graphed yet, but that's at least A through G. And now let's use all of that stuff to graph. Let me pull over these nice points. Yeah, I can use what's my smallest x value? Okay, 0, negative 4, and 2. Those are my zeros. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. So let's see what we got here. We got a 0 at 0, negative 4, and 2. And we have maximum at negative 2.4. I'm going to say negative 2.4. I should go in and run that number. Okay. I should find that coordinate. Okay. Negative 2. What is it? Thank you. What's the minimum? Just that?
8.04.
Okay. And again, we would be going back into the original to see where those coordinates lie. I'm trusting you there. Trusting you. Negative 2.4 comma 16.9, so somewhere way up here. Yeah, really exact. I went through all of that just to put the dot up there. And then 1.1 comma negative 5.04, so somewhere down there. Okay. Now, the inflection point is at negative 2/3, so it's somewhere right in here. That's where it goes from concave upward to concave downward to concave upward. There we go. Questions about that? All right, I'm going to double check that I'm still recording. Oh, no. Oh, it's still going. Okay, good. That would have been bad right there. All right. The farmer problem. The farmer with 600 feet of fencing wants to enclose a rectangular area and then divide it into 4 pens with fencing parallel to one side of the rectangle. What is the largest possible total area of the 4 pens? Let's round to the nearest tenth. Okay. So I have this rectangular area and I'm going to divide it into 4 pens, which means I'm going to cut it like so. So if I call this, what did you guys call this? X? And this Y? Yeah. So that means all of these are X. So I've got 5, 1, 2, 3, 4, 5 X. And 2Y needs to be 600 feet. Okay. I want to maximize area, right? I want to max out the area. And area is equal to X times Y. So now let's find an equation in terms of X, right? So move the 5X over to the other side. So 2Y is equal to 600 minus 5X. And let's divide by 2. 300 minus, I'll just say 2.5X. Okay, so that means my area is X times 300 minus 2.5X. Distribute in, area is equal to 300X, oh, not 3,000, 300X minus 2.5X squared. And if I want to maximize the area, the maximum value would be the critical point of this, this area function. So that means I've got to find the derivative and find the zeros of the derivative. So 300 minus 5X. That's A prime. So that means if I want to find the zeros of that, that would be 300 minus 5X is equal to 0. So subtract the 300, or just add the 5X. So 300 is equal to 5X. And I divide by 5, that's 60 is equal to X. Right? So that means the dimension for the X value is 60. And I don't even need to find the Y value because I'm looking for largest possible area. So I'm just going to run it through that function again. 300 times 60 minus 2.5 times 60 squared. Okay. Okay. 300 times 60 minus 2.5 times 60 squared. There we go. That's much better. 9,000. The area is 9,000. What is this? Feet? Feet squared. Questions about that? All right, let's keep it rolling. Okay, particles moving with given data, find the position of the particle. So I'm given acceleration. In terms of derivatives, what do I have to do? Go backward twice, right? I got to go backward twice. In terms of really, this is just antiderivative, right? I'm given the acceleration. I've got to find the velocity and then the position. The nice thing is that they give me both starting values there. So I want to kick it up. divide by the power, right? So my velocity is 3t squared plus 2t plus 5. That's velocity, that's v of t. And then s of t is going to be 3t to the third over 3 plus 2t squared over 2 plus 5t plus c, or in this case, 4. So just reducing it down, t to the third plus t squared plus 5t plus 4. That's my position function. Good there? Cool. Evaluate the integral. Well, that's easy, isn't it? That's pretty nice. You're welcome for that one. 2x squared, T mode, 2x squared plus 4x from 5 to negative 3. Do you remember when we had to do like rectangles and stuff to find integrals? Yeah. No, you don't. Then you're like, I don't know what you're talking about. So this is top minus bottom. 2 times 5 squared plus 4 times 5 minus the whole 2 times negative 3 squared plus 4 times negative 3. All right, so that gives me, what's wrong? No! Yep, you're right, sorry. Which makes that go away, right? Whew, yikes. Thank you. I was just thrown off by Sydney saying she doesn't remember doing rectangles.
Sorry.
It's your fault. So we've got 5 squared plus 20 minus, and then I've got 9 minus 12. Did you guys get 48 as my area? Good there? Okay, let's keep it moving then. Again, if you guys see any errors or anything, let me know. All right, if negative 1 to 4 is 3.9, negative 1 to 10 is 10.65, and 4 to 10 is what I'm looking for, I can set up this equation. I know from negative 1 to 10 is equal from negative 1 to 4 plus 4 to 10, right? So negative 1 to 10 is 10.65. Negative 1 to 4 is 3.9. And 4 to 10, let's put that as x. So 10.65 minus 3.9 gets me 6.75. And that's the integral from 4 to 10. Good there? Questions there? Question 19. Use FTC 1, Fundamental Theorem of Calculus 1, to find the derivative of the function. So remember, all you're doing here is I'm not actually asking you to find, well, there's one derivative that you do. But remember, to find the derivative of the integral, it's just going to take away the integral sign, right? It's just going to remove this and this. That's going to go away. So what I do here is just plug that in for my x. So 3 over 2x squared minus 1 minus 5, right? That just goes in for x. And then I've got to apply the chain rule because there's a function up top there. And then multiply by the derivative. So 4x. Which then just gets applied to the numerator. So that's a 12x over 2x squared minus 6. And we just divide by 2 everything. So 6x over x squared minus 3. Questions there? Bueno? See? Bueno. What if I just started talking in Spanish? What if I started teaching math in Spanish? Like no bueno. All right, evaluate the integral. Do I need to do any u substitution for this? No, I don't need to do any u substitution because there's not a function within a function. So we've got 3 times the square root of x. Now 3 times the square root of x, that's x to the 1/2 power, right? Which, when I evaluate the integral, I've got to kick it up 1, so 3x to the 3/2 over 3/2 from 1 to 7. So just evaluating that, keep change flip, 3 times 2/3. Cancel, cancel, which is just a 2. So it's 2x to the 3/2 from 1 to 7. And then I plug in top minus bottom. 2 times 7 to the 3/2 minus 2 times 1 to the 3/2. Okay, which is 2 times 7 to the 1.5 minus 2 minus 2, right? Because 1 to the 1.5 power is just 1. 35.04. Right? 1 to the 1.5 power, right? Yeah, 1 to the anything is 1. What am I thinking? That's stupid. Questions? Jared, you're looking confused. You all right? You get something different?
I just plugged something in wrong.
Okay. Does it look the same?
I have everything the same except my FMA, minus FOB wrong, but you just did that with the calculator, so.
I mean, I think I did it right. Let me just double check. 2 times 7 to the 1.5. 7 to the 1.5 times 2. Yeah, minus 2. Yeah, that's right. Yeah. Oh, now our favorite, taking the integral of sine and cosine. I have to remind myself of the rules. Okay, so let's take the integral of cosine. What's the integral of cosine? It's just sine. It's just positive sine. That's what you said, right? Yeah. The okay. Let's go back. Let's go back. Hold on. I gotta go back. I gotta go back to the table.
I believe you, just keep going.
No, that's okay. That's okay. Yeah, you gotta say, okay, what's the derivative of sine? It would be cosine, right? You can always work backward to say, if I take the derivative of that, does it match? Right? So what's the integral of sine? Negative cosine, right? The derivative of sine is negative cosine. Okay, so the derivative of sine is negative cosine. So this is negative 2 cosine x from 0 to 6. And now we plug in. Sine 6 minus 2 cosine 6 minus sine 0 minus 2 sine 0. Oh, 2 cosine 0. Okay, so sine 6 minus 2 cosine 6. Oh, sine 6 end parenthesis minus 2 cosine 6 end parenthesis. That'll give me negative 1.88. And then we have sine 0 minus, oh, I did it again, minus 2 cosine 0. Cosine 0. Negative 2. That's a plus 2. So no, that's not good. Negative 1.88 plus 2 So it would be 1.12. Good there? We're almost to the end of it, folks. Find the general indefinite integral. So what does that mean? That just means I got to add on the what? The plus c, right? So this is 24x to the 6th over 6 plus 15x to the 5th over 5 minus 18x to the 3rd over 3 plus 6x plus c. So in other words, 4x to the 6th plus 3x to the 5th minus 6x to the 3rd plus 6x plus c. Yes?
On 21, I'm not getting 0.12.
Did you get my two values here, negative 1.88 and negative 2?
No.
Uh-oh.
I got negative 2.199 for
When-
the first half.
When you plugged in 6?
Yeah.
I'm in degree mode. I'm in algebra 2 land. Wait, does that matter? That shouldn't matter, right?
Well, yeah, but could you?
Yeah, it would. Yeah, it would matter. Sine 6
No, it would not. Yeah.
minus 2 cosine 6.
Wait, no, it wouldn't.
Yeah, it would matter. This is what you're getting, right? Yeah. I should have been in radian mode. I forgot to switch back over on my calculator. Now 0 would be 0, right? 0 is still the same. So negative 2.1, let's say negative 2.2 minus, and then I think this should still be the same. Sine 0 minus 2 cosine 0. Yeah, that's still negative 2. Okay, so that would be negative 2.2 plus 2. So negative 0.2? Yeah, okay, good. Thank you for bringing that up. I forgot, I'm teaching trig and algebra 2. So I had to switch over. Negative 0.2. They just learned what radians were. Crazy, right? They just learned what it was. Okay. Any other questions on 22 before I move on? Okay, question 23. Evaluate the integral of 3 plus 5x to the 7th. Do I have to do u substitution? Yep. So u is 3 plus 5x. So du is 5 dx. So 1/5 du is dx. Okay, so that means this turns into the integral of u to the 7th times 1/5 du. Or in other words, 1/5 u to the 7th du. So which turns into 1/5 u to the 8th over 8, okay, plus c. Turn into 1/40th, right? 1/40th u to the 8th plus c. And then we plug in u. 1/40th, 3 plus 5x to the 8th plus c. Good there? Okay. So another u substitution. U is 2 plus 3x. So du is 3 dx. So 1/3 du is dx. Now remember that this is like saying 1 over u times 1/3 du, right? Which in other words is 1/3 u to the negative first power du. Right? Did I screw up somewhere? We good? I'm just gonna keep going. We good? Okay. And now, what is the integral of u to the negative first? ln. Yeah. So it's 1/3 ln u plus c. right? So it's 1/3 ln, and we should say absolute value of 2 plus 3x. I didn't take off on the test for that. I didn't take off absolute value. Should be absolute value, but if you put parentheses, that'd be okay too. There's my final answer. 1/3 ln of 2 plus 3x. Let's see. Ladies and gentlemen, this is the last problem. Ladies and gentlemen, this is the last problem here. Right here. This is it. This is it. This is everything. We ready? We ready for this? Y'all ready for this? All right, so we got these two parabolas and finding the area in between the two curves, which is essentially top minus bottom, right? So the integral of blue minus green. Blue was my first one. So 18 minus x squared minus x squared minus 14 dx. Now we have to figure out where the endpoints are. That's where they're equal to one another. So 18 minus x squared is equal to x squared minus 14. So that 0 is equal to 2x squared, adding over the x squared, subtracting over the 18, minus 32. Factor, well, just add over 32. I don't know why I brought over the 32. Whatever. Yeah, I just pull up 2. But no matter what, we get 32 is equal to 2x squared, divide 2, 16, plus or minus quattro. See? -4, +4. All right, let's evaluate a little bit. -4 to +4 of 8. No equal center. Of, we got -2x squared plus 32 dx. Okay, let's do the integral. -2x to the third over 3 plus 32. No, that's divided by. From -4 to +4. Plug in 4. So I've got -2/3 times 4 to the third, plus 32 times 4, 85.3. We got 85.3. Now, what should be happening when I plug in -4? I should get minus a negative 85.3. Right? Let's just double check that. -2. Nobody saw that. -2/3 times -4 to the third power. Plus 32 times -4. So we have minus a negative 85.3. Okay. So it's 85.3 times 2, which is 170 2/3, 170.6.
Could you ever switch your calculator? Could you like switch back to the group? So I got something totally different.
For this, shouldn't matter. There's no trig in this. Yeah, it should only, radians and degrees should only matter with trig. Okay. All right, so long, everybody. Hopefully this video kept going. Let's see. It did. Very good. Okay. Please switch the video over day 2.